Welcome back, everybody. Today is going to be our last section here in Chapter 4. This is Chapter 4, Section 3, Day 2, and we're going to talk about inference for experiments. Exactly what kind of conclusions can we draw from our results of our experiments? And that's all going to depend on exactly how we designed our experiments and even who our experimental units or subjects were. So we have an interesting look at things today. We've got 4.3 Day 2. We're going to be looking at, does listening to music improve GPA? So some students at your school, this is our setup, some students at your school claim that listening to music while studying will help improve GPA. So design a study to help discover if the claim is true. Here are 4 proposed studies for investigating the question of the day. Suppose we found that the mean GPA of students who listen to music is significantly lower than the mean GPA of students who didn't listen to the music. What conclusions can we make? Can we generalize, and can we determine causation? Okay, so 4 different experiments, 4 different experimental designs, or maybe I should say study designs, and then we're going to see how the subtle changes here affect the conclusions that we can make. First of all, let's say that when we say significantly lower here, that's the same thing for our stats brain to say statistically significant, which means that the results could not have happened by chance. The results are so extreme, one mean is so much bigger than the other, that it's very unlikely that that difference of means happened by chance. Okay, experiment 1. Let's get all the students in the statistics class to participate in a study. We'll ask them whether or not they study with music and then divide them into 2 groups based on their answer to the question. So was this a random sample? Well, I don't see any random device here. We're just taking all of the students in statistics class, so I don't think that's a random sample. And then we're going to ask them whether or not they studied music. We didn't assign anybody any treatments here. We're just saying, hey, did you study with music or did you not study for music? So there's no random assignment being done here either. What conclusion can we make? Well, we can only conclude about the students in the class because we didn't sample from a larger population. Our results are confined to just the class. Also, we can show that there is a correlation between grades and listening to music, but we can't show that it's a cause and effect relationship because we didn't do an experiment. So no inference about the population and no causation. Question 2 here. Select a random sample of students from the school to participate in the study. Okay, already we see random sample. We can put a yes there. We're going to ask them whether or not they study with music and then divide them to 2 groups based upon their answer to the question. So this time, just like the last one, we're not imposing any treatments on them. We're just asking them a question and then dividing into 2 groups. So there's no random assignment. It's a yes and then a no. Okay, since it's a random assignment, we can generalize our results to, well, who do we sample? We sampled the school as a random sample from students at the school. So we can generalize our results to the students at the school. However, just like the previous one, we can't show any causation. We didn't perform an experiment, so causation is off the table. For all students in the class, there is a correlation between listening to music while studying and lower GPA. We can make an inference about the population, however, that inference is not going to be causation. Now contrast that with the one up here. We can't infer about the whole population. We can't make our inference generalized to the entire population because we just looked at students in the stats class. But for number 2, since we're looking at students we're taking a random sample of students at the school, now we can make an inference about a population. Okay, moving on to question 3. Get all the students at the school to get all the students in the statistics class to participate in the study. So no random sample. We're going to randomly assign half of the students to listen to music while studying for the entire semester. And then we're going to have the other half abstain from listening to music while they study. Okay, so this time, even though it's not a random sample, now we're assigning treatments to the subjects. This is kind of like the opposite of the one we did before, so we should be able to show a cause and effect relationship because of the random assignment of treatments. However, we can't generalize the population to the entire school because we only looked at the statistics class. Our conclusion is for students in the statistics class, there is a correlation between listening to music while studying and a lower GPA. We cannot make an inference about the whole population, but we can show a causation for the students in stats class. These results may or may not be applicable to the entire school because we only looked at stats students, and there might be stats students may be different than the rest of the students on campus in ways that are related to this study. Finally, question 4. We're going to select a random sample of students from the school to participate in the study. So random sample, yes. We're going to randomly assign half the students to listen to music for the entire semester, and the other half will abstain from listening to music while studying. So this is yes, random sample, yes, random assignment. And since yes and yes, we can generalize, we can make an inference about the entire population of the school, and we can show cause and effect. So the results of this study will show causation for the entire school, provided that we got statistically significant results. So for all students at the school, listening to music is going to cause a lower GPA, not just be correlated with a lower GPA. We can make an inference about the population, and we can show a causation. So that was a nice short little lesson. We can move on to our big ideas, and our big ideas are the following. We've got number 1, inference. What results can what can our results show us? And number 1, if we take a random sample from a population, that means we can generalize our results to the entire population. And number 2, if we have a random assignment of treatments, that's going to allow us to make a cause and effect conclusion. There are other things involved with cause and effect conclusions, or with making a cause and effect conclusion. which we're not really going to go into in this class. It's a little bit trickier than just random assignment, but without random assignment, we definitely cannot show cause and effect. Data ethics. We didn't touch on this, but there are some ethical things involved whenever we do an experiment. So first of all, there has to be institutional review. We have to, if we're doing a actual experiment and we want it to be recognized as good science, we need to turn our results and our methods over to an institution. Usually that means some kind of a scientific journal. And that scientific journal is going to review what we did in our experiment. And then they will assign other experimenters to see if they can replicate our results or get the same results we did using our methods. So institutional review is a huge part of science. This is why whenever you go to a respected journal on science, those results have been vetted, they've been carefully researched, and the results are shown to be consistent and repeatable. That's for a good journal, that is. Moving on, informed consent. This is about the participants of the study, our subjects. If we are going to use subjects in our experiment, we need to make sure that they consent to whatever it is that we're going to apply to them. We have to give them a list of things that could happen, things that might happen, and unless they agree to those terms, it's not an ethical study. And finally, it has to be confidential. If we're going to publish our results, we can't have the names of our participants out there. We need to protect their identities so that their anonymity is maintained. There's another thing that I think about whenever we talk about data ethics, and that's if we're talking about life-saving procedures or life-saving treatments. I feel like it should be unethical, and it is unethical, to withhold that treatment. So, let's say we have a life-saving medication. We can't assign groups in that case. We can't say, oh, you're going to get my life-saving treatment, but you're not going to get my life-saving treatment. That is unethical, especially if we're talking about doctors here. They are bound to save life whenever possible. So that's another thing that didn't make the list here, but you might want to think about. All right, we're going to move on to check your understanding. When an athlete suffers from sports-related concussion, does it help to remove the athlete from play immediately? Researchers will recruited 95 athletes seeking care for sports-related concussion at a medical clinic and followed their progress during recovery. Researchers found statistically significant evidence that athletes who were removed from play immediately recovered more quickly on average than athletes who continued to play. Okay, so let's break down what's going on here. Number one, are we taking a random sample of athletes? It doesn't read to me like we are. We're definitely taking only athletes who had a sports-related concussion. And then number two, if our treatment is going to be removing from the field of play immediately or allowing them to finish the game, are we assigning those treatments? Are we flipping a coin and saying, hey, you just had a concussion. Let's flip a coin to see if you're going to stay in the game or not. Let's flip a coin to see if we're going to apply this life-saving treatment to you. I don't think that's ethical. I don't think that you can do an experiment here. So, can we generalize? Probably not. Can we show cause and effect? Probably not. Can we show a strong correlation? Absolutely. We cannot make an inference about the population, and we cannot show cause and effect. All we can say is that athletes in this study who recovered more quickly if removed from play. Again, there's a few reasons why we can't do an experiment. We can never show that this is a cause and effect relationship, but we can show a very high correlation, which might be enough for some people. Okay. I touched on letter B. Would it be ethical to conduct an experiment? I don't think it is. Like I said before, it's unethical to hold back a potentially life-saving procedure. I don't think there's a whole lot more to say to that. So let's just move on to this. How about, what is this? Nut allergies. Can eating, tree nuts during pregnancy help children avoid nut allergies? Researchers studied over 8,000 children who were born in the early 1990s to mothers who were part of a nurse's health study too. Or the nurse's health study too. It sounds like a very large, a big sweeping study of patients under nurse care. Children whose mothers ate the most nuts during pregnancy at least 5 times a week were significantly, and again that's statistically significant, less likely to develop nut allergies than children whose mothers ate the least amount of nuts during pregnancy, less than 1 per month. Let's break it down. Well, again, did we take a random sample of a population? And I don't see evidence of that. I think we're just taking a look at 8,000 children. And then, did we assign treatments? No, we did not. We did not tell the mother, hey, you eat tree nuts 5 times a week for the duration of your pregnancy. They just took the data as it came. So, letter A, does this study show that eating nuts during pregnancy causes a reduced risk of nut allergies? So yeah, it's a no. There was no random assignment of treatments. And last question for this is going to be, will it be ethical to conduct an experiment to answer this question? And this kind of falls in line with what I was saying earlier. If we have evidence that there is some kind of a life-saving, or in this case, life-altering a life-altering conclusion, then we probably don't want to withhold that. Think about it like this. If we're correct that eating nuts during pregnancy reduces nut allergies, then if we assign a treatment, the treatments would have to be, treatment group 1 would have to eat nuts at least 5 times a week. Treatment group 2 would be, you must eat tree nuts less than 1 time a month. We have a whole group, we've assigned a whole group of mothers who are giving, if it's a cause and effect relationship, we can say that then. They're giving their children nut allergies. That's very unethical. So no, the babies are receiving the treatment and they cannot have conformed assent. That's a different thing than I was talking about. So yeah, there was no informed consent either. So there you have it. We are finished here with Chapter 4. You should be expecting a test on Chapter 4 within the next few days. And, good luck to everybody. And we'll see you for Chapter 5.